Okay, my dear student, you are welcome to my next video lecture. So this video is specifically for the doubt clearance to my previous lecture. Okay, whatever doubt was there for my previous lecture, I'll try to clarify in this video. Actually, one of the viewer asked me one doubt, and the doubt is genuine, and I appreciate the viewer. I have deep respect for such viewer. Viewer asked me like why I haven't taken horizontal component of acceleration, only I have taken vertical acceleration, and the doubt is genuine. See, for competitive exam, kind of JE or whatever competitive exams are there, we have very limited time. So in limited time interval we have to do a lot of questions. So for this type of question which comes under tricky or doable question, and in this type of question we generally have 1 to 2 minutes to solve the question, and in section itself it will be specified that only one option is correct, and this was taken from JE entrance, and in that section it was clearly mentioned that only one option is correct for the particular question. So already we have found that option number 4 was the correct, that is 4.9 meter per second square in vertical direction. If you remember yesterday lecture, or you can watch that previous lecture of mine. So already we got the answer, so we stopped there. But if we want to understand with 100% clarity, then we need to take horizontal component as well. Okay, so if in some case, like let us say vertical component or vertical direction acceleration is not given in the option, or wrong option is given regarding vertical direction and horizontal direction option is there, then in such case student will be in dilemma. So what you need to do, you need to resolve both the component. Okay, no doubt for competitive you should do very fast, but usually in board kind of thing or understanding purpose, detail understanding understanding of the subject is required. Okay, deep understanding is required. So let me clarify the doubt of the viewer, that why horizontal component was not taken. Now let me take horizontal component and let me see what we will get. Okay, for horizontal component of acceleration, see, this is for A. If I do for block A, if I do for block A, for block A, if I do let this point be block. Okay, this point mass I am representing in this way. Now mg weight will be acting vertically downward direction. Here m is the mass of the block, we are considering m to be the mass of the block. Now this is inclined plane. Now I have to draw projection on this plane. So this is the projection. Now see, while drawing projection also I have seen many students, they do mistake usually in board exam. In competitive, though there is no requirement of such case, but in board exam, see this vector is very important. Okay, in physics, like if you are resolving this component mg into two perpendicular component, that is this two, this two component, this component and this component, then this component, this length of this line, see, arrowhead give the direction and this length tells about the magnitude. So see, mg is your primary vector and you are resolving into two component, and these two components shouldn't be, this length of the line shouldn't be longer than this primary vector. Okay, this mg. So you should be careful in board exam, especially in board exam. See, this is inclined plane. Here I haven't put arrow, here I have put arrow, here means up to here only. So this length of the line tells about the magnitude of the vector. So be careful, length, length, length of the line tells about magnitude. So you cannot draw, okay, as your wish, like how much length, whatever. That is mistake. You should be appropriate. in approx at least it should be correct, it should match. Length of the line tells about magnitude, and arrow gives the direction. Arrow tells about direction. Arrow tells about direction for a given vector quantity. For a given vector quantity, this thing you should understand. Okay, this is important. Now, so though in competitive exam you should do very fast, don't go after that size of the line, but in board exam be careful. So see, this is 60 degree, so this angle will be 30 degree. If you resolve, then what you will get, this will be mg cos 30, mg cos 30, and this will be mg sin 30 degree, and this mg sin 30 degree by which this block is being pressed. Block is pressed in this plane, but on this inclined plane, but normal, see, normal acting perpendicular to the plane is equalizing or cancelling that force, that is component of mg, that is mg sin 30. So this is your normal, these two force cancel each other. So this part already done in previous lecture. Now major part is why I haven't taken horizontal component. Now let me complete it. Mg cos 30 degree. So using that Newton's second law, again that Newton's second law, net force, that is F net force, that is net force F net is equal to mass into acceleration. This is also only for this is for inertial frame, that is only for inertial frame, and also you should be careful that mass should be constant. If m is constant, then we can use this equation, okay, otherwise not. But most of the case for +2 for competitive exam, this is sufficient. In most of the 99% it is sufficient, but it is not general, it is special case of Newton's second law. Be careful, okay. That concept, see, if you want concept, if you are preparing for board exam, you can comment, okay, in comment section you can comment, so that I can explain in detail. You can comment in that comment section of my lecture, okay, of my YouTube channel. This everything cannot be explained for competitive exam. For concept, for board purpose, if you want the lecture, then you can, or even bridge course, I am available, you can comment in comment section, okay. Again I am repeating, this net force that is acting on a given body is equal to mass into acceleration. We are habituated to this equation, but this equation is a special case of Newton's second law. It is not the general case. Here why special? Because here we have considered mass to be constant, mass is constant, and reference frame is inertial frame of reference. So you should be careful. Now again that horizontal part, see, mg cos 30 degree, F net force acting on that block A is mg cos 30 degree is equal to mass acceleration, cancel, so this is down the plane, okay. A equal to root 3 g by 2, because cos 30 is root 3 by 2, so acceleration is root 3 g by 2. This is down the plane. Now again let us resolve into component. See, this is for A, okay. For A this value is root 3 by 2g, and let me resolve into two component, that is horizontal and vertical. So this angle already we know, this is how much, this angle is 30 degree, so it will be root 3 by 2 g cos 30 degree. This we have done in yesterday's day before yesterday's lecture, previous lecture. So this horizontal component we didn't took, because already we got our correct option with the vertical component. If we take horizontal component, what will be the case? Let us see, root 3 by 2 g, here this is cos, means horizontal, it will be sine in this case, sine 30 degree. So horizontal, if I denote by AH, this is for block A, horizontal component. This is for block A. So I am removing this vector because I am taking only magnitude here. So it will be root 3 sine 30 is half, so 2 into 2, it will be 4 in denominator. So root 3 by g, it is in horizontal direction, and clearly you can see right direction, means in this direction. Now again for block B, if you see block B, for block B, if you see, I'll do it here itself. Block B, if you see, this is your inclined plane, this is MG acting, let me take M dash, okay, because they haven't specified that both mass is same, anyway it will get cancelled. So M dash G, this will be a normal, and M dash G, that is weight of the block B, has two perpendicular component, one down the plane and one, this is down the, this one is down the plane, okay, here down the plane, another perpendicular to the plane. This see, if you see, this is 30 degree, so this angle will be 60 degree. So this down the plane you will get M dash G cos 60 degree, and this will be perpendicular to the plane, it will be M dash G sin 60 degree. This sine, this and this normal, they are equal and opposite, so it will get cancelled. So only net force is down the plane. So if I again apply that Newton's second law, then M dash G cos 60 is the net force. M dash G cos 60 degree is equal to mass into acceleration, M dash A, which is down the plane. So what you will get, acceleration A down the plane for block B, you will get G cos 60 degree, that is equal to G by 2. So this is, that is down the plane. So net acceleration down the plane, it is G by 2. Now let me resolve again this into two component. So clearly this is 60 degree. So what you will get, this value is G by 2. So if you draw projection here, what you will get, this is 60, so it will be G by 2 cos 60. This part already we did in previous lecture. G by 2 cos 60, this we did in previous lecture. That vertical part already we have taken, okay, in previous lecture. So here only concern is horizontal component. So horizontal component, if this is cos 60, this will be sin 60, G by 2 sin 60. Now what will be the value of G by 2 sin 60? I will write A dash H for block B, that will be G by 2 sin 60, that is G by 2 into root 3 by 2 in right direction, that is equal to root 3 G by 4, that is in right direction. So if you see carefully here, if you see here, this is also in right direction for B, and for A it is also in right direction, and magnitude is same, magnitude is also same. So relative acceleration, that is, therefore, if I write here, therefore relative acceleration in horizontal direction of A with respect to B, if I write in horizontal direction, it will be A dash AH minus A dash H, whose value is same, that is, I think root 3 by 4, right? Root 3, yes, root 3 by 4. So root 3 by 4g minus root 3 by 4g. So relative acceleration, it is 0. And in horizontal direction, so if you see option, there was no any 0 value in horizontal direction. In option first 1, it was 4.9 meter per second square in horizontal direction, but we have obtained 0. So this is the complete answer, okay, for yesterday, day before yesterday question. So the doubt, I think it is clarified. Whoever has doubt, I think it is clarified with the help of this video. Now if you have any doubt further, any doubt means if you have conceptual doubt, if you want to know about Newton laws carefully, see, I want to disclose one thing from this video, that Newton third law. I have been hearing like every action has equal and opposite reaction, every action has equal and opposite reaction. Everyone feel that Newton law, third law, it's very easy, but with 100% certainty I will tell in this video that 99% of Nepalese student, or maybe Indian student, or maybe all the physics student, they do not have clear concept of Newton third law. If you want to know about Newton third law, you can comment in the comment section, and already I have told you, if you want to clear your concept, your base, see, mathematics is very important part of the physics, so math should be, say, trigonometry, geometry, you should be very careful. Vector, you should know it properly in order to solve the physics problem. So if you are preparing for competitive exam or preparing for board, you can ask for the particular topic. I will be clarifying your doubt with the help of video. Thank you.